Hello friends, myself Mr. Rahul Chakole. After taking the problem of ICR for 4-bar mechanism, now we are discussing the second problem of ICR, which is for slider crank mechanism. Before going to see the second problem on slider crank mechanism, already we have discussed regarding the ICR in the previous problem. We have seen the properties of IC, then we have seen the types of IC, then how to calculate the total number of IC for a given mechanism. That formula we have seen. Let us apply this information and the different steps given to solve the problems of ICR by taking the problems of slider crank mechanism. So let us see the problem of slider crank mechanism. In a slider crank mechanism, the different length of links are given. The crank AB is 6 cm. The RPM of crank 300 and it makes an angle of 30° from IDC. It is given. The motion of the crank or the rotation of the crank is given clockwise. The length of connecting rod is given 25 cm and the unknown is that you have to locate all the IC and also the angular velocity of connecting rod. Again, you have to determine the velocity of slider. So, how to solve this problem with the help of ICR method? First of all, you draw the configuration diagram with the help of scale. Here I am choosing the scale as 1 centimeter is equal to 10 centimeter. So you draw the same sketch, same mechanism by using the scale. I am giving the name as configuration diagram. Then after making the configuration diagram, you calculate the angular velocity of the crank because the RPM is given. So from RPM value, you can easily calculate the omega of AB. So the omega of AB comes 31.41 rad per second. So after calculating the angular velocity of crank AB, the third one is the number of IC in the mechanism. So again, this mechanism is of 4-bar mechanism, or we can say it's a slider crank mechanism having the number of links are 4. So by keeping the value of small n, that is 4, in the equation, you will get the 6 IC. So the total number of IC for a given slider crank mechanism problem is 6. So again, you have to make a table where the column number 1 is the links and the horizontal we are writing the ICR, that is the total number of ICR obtained from the given for the given problem. So in the vertical column I have mentioned the number of links given in the mechanism, it is 4. So uh, I have written 1 2 3 4 in vertical column and the total number of IC obtained because of these links I have mentioned here on the horizontal. So keep it for link number 1, you this is I12, I13 and I14. So suffix 1, the first suffix is the link 1. So you fix this suffix 1 as a fixed one and then you go onward, that is after the 1 it is 2. So I have mentioned here I 1 2 means suffix second is changing by onwards value. So in the next column I see 1 3, 1 is fixed one, that is the link number 1, that is the row number 1 and next after the 2 the next suffix is 3. So I have written 1 3. In the third column I have written 1 4 where 1 is fixed one, that is a link and 4. So after the 3, it comes a 4. So I1 4. Then in the same way, for link number 2, which is the second row, so the link 2, that is first suffix 2, I have fixed 1. I kept the first suffix 2 as a fixed 1, and then after the 2, the onwards value comes a 3. So I have mentioned here I 2 3. In the second column, again the first suffix 2 is a fixed 1. So after the 3, the next suffix value comes a 4. So I have mentioned the second suffix as 4. So I 2 4. So in the same way for the row number 3, that is link number 3, you will get I34, and for link number 4, so it is a I4 5, but the 5 you can't write because the maximum number of links for the mechanism is 4. So you don't take this I4 5 for link number 4. Okay, so it is exceeding. So after summarize all the IC in the table, then you go for sort of this IC, which IC, whatever the ICs you are possible to locate by observation, that is a fixed IC and a permanent IC, you can mark with the help of some circle on this particular table. Okay, so here I want to uh, then I14, I23, I34. It is obtained or it is visualized easily. Okay, so this IC can visualize by observation. So I make a small circle on that. Okay, so let us see the problem. So here one is fixed one, second one is crank, the third one is connecting rod, and the fourth one is the slider, which I have given the notation as C. Okay, so IC is formed by link number 1 and 2. It is I12. It is always at the contact point, or we can say the joining point or intersecting point. Then IC 3. It is formed by the link 2 and 3. And then IC 3 and 4. It is again joined by the link 3 and 4. And IC of slider with respect to fix. It is always lies at infinity. So I14 is lies at infinity. So I have drawn the perpendicular line to the line of action of the slider. So in IC made by obtained by the slider, that is I14, lies at infinity. Okay, so these are the ICs. So out of that 6 IC, the IC 1 2 and IC 1 4, it is a fixed IC. Okay, because it is formed by the fixed one, where this okay, and then 2 3 and 3 4, it is a permanent IC. Okay, so these 4 IC you can locate by observation, and it is clear cut shown in this circle, and it is already we have shown on the mechanism. Okay, now the question comes how to locate the remaining 2 IC. Which 2 IC? That is 1 3 and 2 4. Okay, so for locating these 2 IC, which comes under the category of neither fixed and nor permanent, which is not possible to locate by the observation, and you have to take the help of Kennedy's theorem. So what is Kennedy's theorem? According to the Kennedy's theorem, if the three bodies move relative to each other, uh, then they have three instantaneous center, and all this IC or instantaneous center lie on a straight line. Okay, so according to this theorem of Kennedy's, you have to locate the two IC 1 3 and IC 2 4. So for locating these two IC, again some steps are given by the Kennedys, and you have to follow. So first of all, you draw the small circle, then you write down the number of links on the circle 1 2 3 4, and whatever the ICs are uh, possible to locate by observation, you make that you connect this IC by dark line. So IC 1 2, I have connected by the dark line. Then 2 and 3 links 3 and 4, and links 1 and 4. So because of that joining by the dark line, it means that this ICs um, priorly. Now the next IC is 1 3 and 2 4. So one by one, let us join 1 and 3, and by joining the 1 and 3, the two triangles are formed. So triangle 1 2 3, it is one triangle that is on the right side, and 1 4 3, it is the triangle which is on the left side. So because of the half triangle, the two ICs are formed. Let us consider the right side triangle, half triangle, the I12 and I23. It is the two ICs are formed because of half a triangle of the right side, and IC14 and IC34. It is the two ICs are formed by the half of the triangle which is the left side. So if you draw the lines through that IC, then you will get the IC13. Okay, and in the same way, by joining the 2 and 4 by the dotted line, again you will get the two triangles, half triangles, that is on the right side. Again the two ICs are formed, IC2 3, IC3 4, and another left side half triangle, you will get another two IC, that is I12 and I14. So by this 4 IC, the two IC from the right side and the two ICs of the left side, obtained by joining the dotted these 2 and 4 by the dotted one. So through that 4 IC, if you draw the line, then these lines are intersecting at one location, and I have given the um, points as 2 4. Okay, so the 2 4 is the point where these 4 ICs are uh, lies. Okay, so in this way you have to locate on these two IC13 and IC24 with the help of Kennedy's theorem. Now what is the unknown? Okay, the unknown is the angular velocity of link number BC, that is link number 3. So again we have the angular velocity ratio theorem, where omega x upon omega y is equal to I1y Ixy divided by I1x Ixy. This is the standard formula given by the angular velocity ratio theorem. You keep the value of x is equal to 2 and y is the link number 3. So you don't know the omega 2, you know the omega 2, and you know the distance between this IC 1 3 and 2 3. You multiply by scale, divided by the distance between the IC 1 2 and 2 3. You measure this length, you multiply by scale, and then you will get this values of IC. Omega 2 you know already, so it is unknown omega 3. So in this way, omega 3, that is omega of link number BC, comes 6.59 rad per second. And the second unknown is, already we have located all the ICs in the mechanism. And now the third unknown is the velocity of slider. So again we have one formula, Vx is equal to omega y in bracket I1y Ixy. Okay, so here Vx, so I am assuming the x is a link number 4, that is a point C, whose value of velocity is to be determined. So I am noting the velocity of C, means C is nothing but lies on the slider. So slider I have given the name as link number 4. So velocity of C, that is velocity of 4, is equal to y means it is connecting with the connecting rod. So omega is y is equal to link number 3. So Vx, that is Vc or V4, is equal to omega 3 bracket I1y I13 Ixy, that is I43. So accordingly the distance between the I13 and I34, you measure this length, you multiply by scale, and that values comes into omega 3. Omega 3 is already known you, So by keeping all that value, you will get the velocity of sleep, which is 113 centimeter per second.